How many minutes do I have?
So you have top 30 minutes.
Okay. Okay, cool.
Yeah.
Cool.
Is that plenty for you?
It's fine.
Okay. I believe in you. Okay. I am gonna cut my video and mute myself and then go ahead and get started at when you're ready.
All right, thank you.
Okay.
Hello, everybody. I'm Idrees Ibraheem. Even though this is a pre-recorded call, I'll be in the chat, still available to answer questions if anyone has anything that is confusing or not understandable or not clear. Okay, so let me share my screen. All right, so today I'll be making a bunch of presentations about how to use HashiCorp to Terraform and Ansible to manage a Kubernetes cluster and also provision resources within or manage resources within the cluster. But before I begin, I would like to first of all begin by setting up the cluster so that by the time I'm done with my presentation, what I will be doing will be provisioning the resources within the cluster so that we don't have to wait for that for the whole provisioning of the cluster to begin before we are done with the presentation. So before I begin, let me show you guys what the cluster looks like on GCP, because I'm using GCP as my cloud provider. I'm provisioning the Kubernetes cluster. So this is what it is. I have no cluster ready. This is my project. There's no resources, nothing, everything is empty, nothing is there. So going to, this is the directory, project directory where I'm where the code is, the code base, the source code and everything I'm using to provision the cluster and provision the resources within the cluster. So I have directories like Ansible, Kubernetes, and Terraform. All these directories are just created there for you to be able to easily manage where your source code for the different tools you're using are going to be, and also makes it easier for you to undo versions or even ordinary configuration management. This makes it modular, much more easier for you to use. So the first thing I'm going to do is go into the Terraform directory and then run Terraform. The first thing you do when you are in the Terraform directory or in the Terraform project is you initialize the directory first to use Terraform, because if Terraform is not initialized, you won't be able to use Terraform to communicate with your cloud provider, and then in essence, you won't be able to create resources within it. So you need to initialize Terraform to use your chosen provider, which I am using Google's provider since I'm communicating with GCP's GKE, that's Google's Kubernetes engine. After initializing Terraform, you plan your resources. What Terraform plan does for you is it's sort of similar to when you want to build a house. You have a piece of land and you don't know what to do with it. So you call someone who has the technical knowledge of planning, designing a plan for you that would fit what you want to build on the piece of land. This is similar to the Terraform plan is also similar to that in the sense that you have a bunch of configurations and you would like to see what the configurations look like before they are provisioned in the cloud. So when you run Terraform plan, you see a bunch of outputs that would show you, based on your configuration, what will be created in the cloud. And using this, you can decide that, okay, so, well, I don't think I need a cluster anymore. Let me change it. Or maybe I don't like the name I've given the cluster. Let me change it. it depends on you. But what this just does is gives an opportunity to plan and have an idea of the resources that will be created in the cloud. Then after planning, then what we're going to do now is apply the resources in the cloud. So what this is going to do for us now is create the Kubernetes cluster in GCP's GKE. But since it's going to take roughly 6 or 7 minutes, we are going to let this run while I go back to the presentation. So by the time we're done with the presentation, we should have our cluster up and running here. Now back to the presentation. So again, I talked about deploying and managing the minimal application in the Kubernetes cluster with Terraform and Ansible. So what are Terraform and Ansible and Kubernetes? All these tools are basically things we use in DevOps. They are tools we use in DevOps for automation mostly, basically for automation mostly. But then we also use them for, especially Terraform and Ansible in this case, we use them for configuration and change management and for continuous delivery. And Kubernetes, mostly we use that for, orchestrating deployment, since Kubernetes is mostly used with containers and in situations where you want the application to be highly tolerant, highly available and fault tolerant in cloud. So what are some of the use cases we have for each of these tools? Starting with Terraform. Well, for the most part, Terraform is mostly used for automation. If you have a lot of steps, maybe for example, you want to, let's say on Amazon, you want to create an EC2 instance and you don't want to have to log in and then sign in, do your authentication, go through all the authentication you need to go through, look for the EC2 dashboard, click on launch instance, and then run through all the settings and all that stuff. You can use Terraform to do all that with just the minimal configuration, and being able to do that with Terraform is just basically automating your whole step, of having to log in, having to do this and that, because all you have to do is just provide the Terraform script with your credentials, your access and secret keys, or in case of GCP, you provide it with your service account, JSON file, and it will provision these things for you easily without any stress. All you have to do is just run a bunch of commands. And it's that automation that is mostly important with a lot of these tools, because with that, you can do so much in so little time and achieve, and have more time to do a lot of other things that will add value and solve a lot of business problems, create solve a lot of, create a lot of solutions for a business, as the case may be. And then the second real use case is of server provision. Like I said, when you are automating, you also have the ease of provisioning your servers in the cloud without having to do so take so many manual steps. And then also ease of managing your configuration. This is also important because with Terraform, a lot of things have been, abstracted out for you. You don't have to write so many bash scripts that will be jumping to too many steps, and then you have to go through the manual, long steps of managing this bash script. All you have to do is have your Terraform, configurations as modularized as possible, and then, having that modularity, it makes it also easier for you to change things, update, remove, and basically, like I've said, managing everything easily. You know where to look for things, you know where to find what you need to find. And even variables are also managed easily, and which makes it easier for you to dynamically provision your resources in the cloud, as the case may be. And then there's also the planning of your resources, which is what I showed while I was running the command previously. Then also infrastructure as code. Infrastructure as code, the use case infrastructure as code goes along with this of management of your resources, because infrastructure as code just means that you have turned all the manual steps you are taking to create your resources in the cloud. You've turned them into code. and then you don't have to jump through all those hoops anymore. All you have to do is run your script, and you're good to go. And the next tool is Ansible. Also, the use case between Terraform and Ansible is not so far off. It's just that for the most part, you have to just, you yourself as an engineer, you need to sit down and think about your use case and think about which is the best for you to use in a particular case, or which is the most appropriate for you to use in a particular case. Because sometimes, depending on the use case or depending on the solution you're trying to create, you might say that, okay, I want to use Terraform to write all the solutions I want to create. And then occasionally you'll be like, well, maybe Ansible is what works for me. So there's no one size fits all solution. You just have to come up with your own. You have to decide yourself, like, okay, so I think this is best for me. This is the best for me. So it's like in Terraform, the use case here is also automation, server management and provisioning. You're sort of managing your config, app deployment, infrastructure as code, and then you can check out the links underneath each of the tools to know more about how, check documentation out to know more about how to use these tools and kind of use cases you can use it for, even the one that's not listed here. For Kubernetes is not really a tool per se. It's mostly, for me, I feel like it's mostly technology, because you don't exactly use Kubernetes, but you have different tools you use to, you have different tools that are native to Kubernetes that you use to manage your cluster, create a cluster, manage your cluster, the resources within the cluster. But the use cases Kubernetes itself came to, help us make it, help us assist us in, being able to use containers easily, or create clusters and use containers easily, and also scale our applications faster, and also be able to create an application or deploy an application that is highly available to our users, and also in situations where there are issues where some containers are crashing or they are not healthy, it's able to, Kubernetes is able to help us reprovision those resources and then ensure that as much as possible we don't experience any downtime. And there's also use of deployment and rolling updates to your cluster. What this means basically is that with Kubernetes, you only have to create, most of the time, depending on your use case, you only have to create your cluster once. And when your cluster is created, all you have to do most of the time is update the cluster with new, if you have new updates to your code base, you update the cluster, as the case may be. And rolling update basically just means that depending on how huge the update is, you don't have to pull down all the resources before the update is done. The update can be done in place, and the update can be done in place, and the users will not even notice any downtime, because you don't have to pull every resources down or what have you, and then you create new pods. And then another use case with Kubernetes is it works very, very well with containerization tools like Docker, Containerd, and so on. But Docker is the most popular, so that's what most people use Kubernetes to deploy with. And then you can also use Kubernetes to deploy applications that are really modular, in the sense that if you have, for example, an application that has a front end and a back end, maybe an API back end, the front end, maybe React, and you want to deploy these two applications, and you have a cluster, you can, all you need to do sometimes is, in that one cluster, provision those two different parts of the application, those two different microservices, deploy them in different namespaces. And then deploying them in different namespaces means that you can easily know where to find one particular application and debug, or check anything within it, and the other. You don't have to, if you need to find anything within the front end namespace, all you have to do is check the front-end namespace for your pod or your resources. And the back-end namespace is the same thing. And in that kind of scenario, it also makes it easier for you to, put everything within one particular place easily, and also manage your resources as the case may be. So the namespaces feature is one of the, one of the many features that Kubernetes has that makes it easier for you to deploy your applications easily without having to worry about creating different different clusters to manage different things if there's no need for that kind of solution. So, and then moving on to the last one, Kubernetes is a technology and a tool that is very, 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 very perfect for a product that is built on microservices. And if your product has different microservices, you have the payment microservice, you have the logging microservice, you have the image processing microservice, as the case may be. Kubernetes is the best for you. Why? Because all these microservices are things that need to, communicate with each other at some point. And also there are things that may not even be as big as you may think, as most, microservices, in which case you can put them in these different microservices within different namespaces and you'll be good to go. Or you can even put them in different clusters, depending on whatever your use cases. But basically, Kubernetes is very, very useful for microservices. Microservices are, services that are mostly doing one particular thing. And in doing that, they are able to, when they fail, they're not affecting every other services that also uses them. So as opposed to the situations where one monolithic app, a service fails with a monolithic app, and then everything just goes down. So microservices Kubernetes is really perfect for the microservice architecture. Now, how does Terraform and Ansible work with Kubernetes? An example code of how Terraform works with Ansible and Kubernetes is something like this. This is an example code of Ansible. But before I speak about this, let me talk about example code for Terraform first. With Terraform, most of the things you need to do, you don't really need to do so many things if you are starting out to learn how to use Terraform. You don't really need to do so many things to create a cluster. You can work with the most minimal configuration and you have a cluster that would be created for you to use, to test, to play around, break things and things like that. But of course, as you go along, you get to learn that there are so many things you can do with a Terraform configuration creating a cluster for you. And this is a snippet of what what can be used to create a minimal cluster. With this, you can create a minimal cluster in GCP, and that's just all it minimally takes to create a cluster. And with that, you can provision your resources within it, and you'll be good to go. This is an example of an Ansible module that you can use for playbook. This is a playbook, but in the playbook you have the Kubernetes module that you can use to create resources within the cluster. So this is just an example that I used where it points to this module assumes that you already have your Kubernetes object in these YAML files, something like this, and then you point to those YAML files, and then you point the module to the YAML files, and then Ansible will take them and then provision them within your cluster. Of course, the assumption is also that you've already made necessary connection to your cluster in the cloud before you run your Ansible playbook. And then this is an example of a Kubernetes object creating a service in the cloud. This is a service, and this is a load balancer service. This is a Kubernetes object. This is what we used to create a Kubernetes service in the cloud. Of course, you can also create these things from terminal, just using kubectl to create these things. But since what we are trying to practice is infrastructure as code, we turn everything to code, and this is what it would look like. Now let's go back to demo. For the demo, this is the code base here that I'm using for the demo, and the steps you can. But since I already started running the Terraform apply command a few minutes ago, it has completed provisioning, and now we have our cluster up here running. So the cluster, the only thing that is created right now is the cluster. We have no resources within the cluster. Now what I'm going to do next now is connect to this cluster by clicking the connect button here, and then you have this command that shows you how to connect to the cluster. So I'm going to copy it, come to my terminal here, and then paste the command here, and then connect to it. By the time this is done, you see that my terminal prompt changed from Minikube to this, and that just shows that I'm connected to the cluster. Now, before I run the playbook, let me come out of this Terraform directory and then come back to this directory where I have my Ansible directory. In the Ansible directory, you should see I have a playbook directory. Let me show you in the browser. In the Ansible directory, I have the playbook, which just has a minimal configuration. It shows how I'm connecting to my host, how how I'm handling sudo rows, and then the rows itself. The rows are just where my task. Ideally, my task should be here, but since I'm abstracting out my modules, I have my task here under rows, directory, rows, Kubernetes, and task. And then this is my own configuration pointing to my own Kubernetes object here. If you're using this repository, you would need to, when you clone this repo, you must make sure that you use the absolute path to where this repository is cloned, so that your Ansible playbook will be able to find the path where the objects are. So going to the directory where the objects are, we have deployment, which just deploys our application using an image that I already created and saved in my Docker account. And then we have our service object. It's just something very minimal. Now, going back to the terminal, the first thing I need to do is to export these credentials, the variable Google application credentials. This is done so that Ansible would be able to find, because Ansible would always look in the environment for this variable in order to be able to authenticate with our Kubernetes account on GCP. If you can't find it, it won't be able to provision our resources. So we need to make sure that we point this variable to the absolute path where the credentials is at, so that to be able to find it. And then when that is done, and we are connected to the cluster, the next thing to do would be to run Ansible playbook. The command Ansible playbook pointing to the directory where Ansible playbook is at, and then also to the playbook file. The reason why I'm using the flag V is because I want it to be in verbose mode so I can see the output as command is running. Okay, so I need to run it with sudo. That's what this means. So now we wait for the resources to get created in the cloud. Okay, so our deployment object has been created. Now it's creating our load balancer, which is our service object. So now that this is created, we go back to the browser. First, let's check our workloads. See, this is so just created, and also this is also being created. Now let me click on this so that you see what is going on within it. It's not like there's a problem, it's just that because it is being created for the first time, it doesn't have minimum availability. So because the minimum availability is supposed to be 3 pods, and since 3 pods are not available, it is always going to say there are no minimum availability, and until when the pods are available, since they're still being created, not available yet. When they are available, then it changes from this warning, this danger notification, to being green and all good. So let's give it a couple of minutes, couple of more seconds. So shouldn't take more. Yeah. So everything is fine now. Because everything is green. Checking the services also, everything is green. If I click on this, one of the things this service, load balancer service, does for us is it automatically creates the load balancer for our Kubernetes cluster in the cloud. And when the load balancer is created, an IP address is also automatically attached to it. So when I click on this, it should take me to the app I deployed. And that's it. That's just how you can deploy a minimum Kubernetes cluster with the minimum configuration. And using this, you can extend even the configurations we have here to deploy something bigger, much more than this. This is the configuration for create cluster. This creates the cluster for us. This attaches node pool to the cluster. And what this node pool does basically is just to easily manage and bring all instead of creating default node pools that your cloud provider will probably create for your Kubernetes cluster. This helps you bring everything together on your cluster easily. So it's not just something that is randomly showing up in your Google Cloud account, because the thing is that when a Kubernetes cluster is created, it needs virtual machines. When a cluster is created, you need virtual machines to run. And if I check my VM instances dashboard page, you will notice that I didn't create this VMs myself. This was created by Kubernetes itself. So because it needs VMs to work. But if you don't create your node pool yourself, the cloud provider would help you undo that yourself. So it is always better to just undo the creation of your node pool yourself and manage what you would like to be part of the configuration of your node pool and what you wouldn't like to be part of the configuration of your node pool. Like, for example, what kind of machine type do you want? Because like I've already said, it's also virtual machines. So what kind of machine do you want? Because NO standard is like the default, but do you want something bigger than that? If your workload is really huge, do you want something bigger than standard 1? Do you want something lower than that? We can match things like that here. And then this is the provider configuration that tells Terraform where to find, that tells Terraform the provider to use, and also the provider also how to connect to your cluster. You have TF file. This is just for managing. These are for managing variables, and then you have this create directory where you have to put your service account files, as the case may be. So that's all for me. This is the app. See, it works and everything is cool. Thank you very much. That's the end of my presentation. I hope you were able to learn one or two things. If you have any questions, please don't hesitate to ask in the chat. I would be glad to respond to them. Thank you.